So welcome to the class. Today we will be seeing what is refraction, the type laws of refraction, lens, what are lens, the type of lens, sign convention and the image formation by lens. Quickly moving on to the topic refraction. So considering a medium glass or considering a surface glass, if a light is incident if a light is incident on your glass, it passes through the glass. Since it is transparent, the light passes through the glass. Alright, so what is the medium of light? Here it is air. So light travels in air here and it hits the glass. It travels through the glass and it again passes into air. So the light actually travels through this surface glass. So when a light passes from one medium to the another, it is called as refraction. The medium here is air, the medium here is glass, and again it passes on to air. So refraction is nothing but passage of light from one medium to another. So what is Snell's law, or what are the laws of refraction here? For that we could take an example given in your textbook. Take a glass slab So consider a rectangular glass slab. Let us name the corners to be A, B, C and D. Now let us make a light incident on this glass slab. Let us make a light incident on this glass slab. Let us name the incident light to be E, F. Okay, now the light is incident on this surface of the glass slab and let us name it to be O. So what happens here? The light is traveling through air here. Yes, and it hits your glass slab at O. Now the light has to travel, since it is the transparent glass, the light has to travel through this glass and come out of the other side of the glass. So how will it travel here? Will it travel as the same path of the incident light? No, it will make a deviation here. So it will make a deviation here and it travels through this surface and hits the other side of the glass slab. Let us name it to be O dash. And it will emerge here, O dash. And it will emerge through this glass slab. So let us name it to be G H. The emergent light ray, let us name it to be EH. GH. So as you can observe, the passage of the light has taken a shift here when it has entered the glass slab and it has again taken a shift at this point O dash. When it is coming out of the glass medium into the air, it has taken a shift in the path. So how can we observe the shift is, you draw a normal, you drop a perpendicular here, drop a perpendicular here, and the angle here is called as the angle of incidence. The angle here is called as angle of refraction. Now at this surface also you draw a perpendicular. So here this is your incident ray, right? At this surface CD, this is your incident ray. So this is I2. This is your emergent or refracted ray R2. Alright. So if you observe here, if the light had to travel in the same path, it would have taken this path. If it had to travel in the same line, it would have traveled in this path. Let us assume to be LP. But why does the shift of the light rays takes place? Why does the shift of the light rays takes place here? Because the light EF is traveling here in air, and once it hits the surface AB, it is traveling through the medium glass. Again at this place you observe the light is at this surface CD, the light is traveling through glass, and at the point O dash it is again traveling into air. So the light is traveling from air to glass, from glass to glass, yes, and from glass to air. So here we have some angle of incidence and refraction. Here also we have some angle of incidence and refraction. Now analyzing this and arriving at results, what does Lenz's law say is, the angle of incidence is always equal to the angle of incidence, the angle of refraction, the angle of incidence, the angle of the incident ray, the incident ray, the refracted ray, and the normal, they all lie in the same plane. So this is the first observation. The second observation is the sine of angle of incidence, the sine of angle of incidence to the sine of angle of refraction will always equal to a constant. Okay, incident ray is the refracted ray. The sine of both the rays will be equal to a constant. This is the Lenz's law observation. What is refractive index? What is refractive index? Refractive index is represented by N. So if you take the previous diagram, so what is the refractive index at the point O? At the point O, refractive index is represented by N, and it is given by speed of light in medium 1, speed of light in medium 1 to speed of light in medium 2. Okay, this I am observing at point O. So this will be represented as N21. So what is the speed of light in M1? That is the speed of light in air. V1. The speed of light in M2 will be given by speed of light in medium 2 is glass. So it will be V2. If you observe at point O dash, if you observe at point O dash, what is the refractive index here? N12. That is speed of light in medium 2 by speed of light in medium 1. So what is the medium 2 here? It is the air again. This is medium 1 and this is medium 2. Speed of light in medium 2 by speed of light in medium 1. Alright. So that is refractive index. So refractive index generally is the ratio of the light, the speed of light in the two mediums which it is traveling. Now going to lens. So what are lens? What is a single lens? How does it look like? This is a single lens. So a combination of two lenses can form different types of lenses. If you how can you combine two lenses? You could either join one lens and the second one like this, or you could join them inward like this. So you can actually form two lens. To form a pair of lens, you could actually join the two lenses like this or two lenses like this. This type of lens, when you form the when you join the lenses by the curved surface outwards, it is called convex lens, and when you form the curved surface inwards, that is called as concave lens. So a lens basically has an optical center and a focal point. Alright. And a center of curvature. The center of curvature and the center of curvature. Now we are talking about the convex lens. Here we are going to join two lenses, and the two lenses are going to have an optic center which is common. So I have joined and I am going to draw it as a single figure. Okay, so the optic center is going to be common, and these two lenses are going to have focus points f1, and this side of the lens is going to have another focus point f2, and at a distance there is going to be center of curvature c1, and here it is going to be center of curvature c2. or the center of curvature you could write it as 2f1 and 2f2, because center of curvature is the radius of curvature. So R is equal to 2f, right? That is what R is nothing, radius of curvature is nothing but C. So you could also write it as 2f1. And how will your optic centers and focus points be on concave lens? Same. Concave lens is represented by this type of representation, and this is also going to have an optic center, a point f1 and a point f2 and 2f1 or c1 and 2f2 or c2. Now let us discuss how the image is formed by these two types of mirrors, these two types of lenses. Same like your mirrors, your lens also has some laws, some patterns in which the refraction takes place here. So consider a convex lens and a concave lens. This is your optic center, f1, f2, c1 and c2. If suppose your light travels and you are keeping an object here, and if your light travels parallel to the surface, parallel to your principal axis, this is your principal axis. If your light travels parallel to the principal axis, then the refracted ray will pass through your focal point. The refracted ray will pass through your focal point. Same for your concave lens. This is the object. If your light travels parallel to the principal axis, it travels through the focus point. I'm sorry. In case of your concave mirror, same. If your incident light is passing parallel to the principal axis, then the refracted ray, this is will actually bend outwards, right? It will diverge, but it virtually passes through the focal point. So the object and the image are on the same side in terms of your concave lens. Here the incident light and the refracted light are on the opposite sides in case of your convex lens, or in other words you can say your convex lens is converging and concave lens is diverging. This is just the opposite of your mirror. In case of your mirror, concave mirror is converging, whereas here concave lens is diverging. Alright, this is the first case. The second case, let us consider the lens, optic center f1, f2, c1 and c2. And now my incident light is traveling through the focal point. So what will happen when the incident light is traveling through the focal point? through the lens, it will travel parallel to your principal axis. The refracted ray will travel parallel to your principal axis. In case of your convex mirror, this is the optical center F1, F2, C1 and C2. My instant ray is going to travel through the focus. Alright. And it so let us consider the concave lens now. It has an optic center. So let us consider the concave lens here has an optic center O, F1, focal points F1, F2 and C1, C2. Alright. Now let us consider the incident ray passing through the focus. So as such, it does not pass through this focus, but it appears to pass through this focus. So actually the instant ray here appeared to has passed through the focal point F1, is whereas here it appears to pass through the focal point F2, and the refracted ray is actually parallel to your principal axis. Alright. So here it does not actually pass through the focus, but it appears to pass through the focus. So if you observe the instant light and you virtually virtually try to trace the path outwards, you could actually map it to F2, and the same light it actually gets refracted parallel to the principal axis. So the incident light does not actually pass through your focus, but it appears to pass through your focus in case of your concave lens. The third point, where your incident light actually passes through your optic center. If your instant light passes through the optic center, it uh, it it follows the same line without any deviation. Okay, the emergent ray or the refracted ray will not get deviated, but will pass through the same line, which is the same for your concave lens also. If it passes through the optic center, the instant light, it traces the same path without any deviation. So these are the laws, or these are some uh, ray diagram rules which you follow for marking the image of concave and convex lens. Now moving on for the sign convention. The sign convention of the lens are same as that for your mirror. So when you take a 4-degree axis, x minus x, y minus y. So anything, if suppose this is your optic center, anything on the left of your optic center will have negative sign, and anything on the right of your optic center will have positive sign. Anything on your upward direction will have positive, and anything on the negative, I mean downward direction, will have negative. So this is same as that for your mirrors also. In the mirror also you'll have the same type of sign convention. Only thing here which is differing, like only added thing here is uh, according to the convention, the focal length of a convex lens is positive and that of concave lens is negative. Focal length of concave or convex lens is positive. Convex lens is positive and focus of concave is negative. Yes, you can easily see why, because see here the focus which you are considering here yes, the focus of convex lens is positive and concave lens is negative. And other than that, if you take the object now, if it is placed here, then the distance of the object will getting the negative sign because it is here. If your image is formed here, if this is the image formed on the left side of the lens, then it will get the sign convention of negative. If the image formed is here in the right side of the optic center, then it will get the positive sign. Alright. Now moving on to the lens maker's formula. Lens maker's formula. It is given by 1 by V minus 1 by U is equal to 1 by F. This is your lens maker's formula. And the magnification factor is given by M is equal to height of the object by, height of the image by height of the object. This is image and it is object. Alright. I'll give you a tabular. I have given you a common diagram. Now look at the tabular column. It says if you keep the object beyond or at infinity. So if you are keeping the object here at some place infinity, then you'll get the image of the object at infinity. So the rays will pass through the lens and it will all converge at your focus. Here is where you will get the image of the object. And how will the image of the object be? Be very much smaller in a point sized, and it is diminished. Diminished means it is much smaller, right? Whereas in your concave lens, if you keep the object at infinity, so this incident light is parallel to the surface, and if it passes through the optic center, so first let us complete convex lens and then move on to concave lens. Now second, the case is if you are keeping the object beyond f1, this is where you are going to keep your object beyond 2f1. I'm sorry, you are going to keep the object beyond 2f1 or c1. This is where you are going to keep your object. Then the incident light, which is parallel to the principal axis, will get refracted at the focus, right? And the instant light passing through the center of curvature will follow the same line. Here is where you are going to get your image. It is going to be inverted. If this is going to be A, B, this is A dash, B dash. This is how you are going to get the image if you place your object beyond C1, but not at infinity, at a measurable distance. Now the third case, if you are going to keep your object at F2 at C1, if you are going to keep your object at C1, and here the image formed, see, right? So image formed here will be before or in between F2 and C2. If you keep your object at C1, exactly at C1, so incident ray, reflected ray, refracted ray, right, through the optic center will pass, and where you will get so these lines will meet. This intersection point will be exactly at C2. Here is where you get the image of the object. It is AB. It is B dash, A dash. This, A dash, B dash. It is going to be inverted and real. And also the image size will be same as that of the object size. The third case, fourth case, let us keep the object in between F1 and F2. F1 and 2F1. 2F1, F1, optic center, F2, 2F2 or C2. So I am going to keep the object here. Now it is going to hit here on the lens, and it is going to pass through F2, and through the optic center which is going to intersect at some point which is beyond 2F2. So here is where I am going to get the image A, B, A dash. The image is going to be beyond 2F2, and it is going to be inverted and real, and it is going to be enlarged or bigger in size. And the last case, I am going to keep the object between focus and optic center. Okay, we will see first at optic center. What will happen if you keep the object exactly at optic center? So both the lines will be parallel and they will not intersect. So what we will see, we cannot actually see the image here. In this case, if you keep the object at f1, and we will say that the object could be, image would be seen only at infinity. We could not actually see the image, and we would say that it will be at infinity. Last case, I'm going to keep the object before f1, and where will be my, so if you actually see the path, always my parallel incident ray will travel through the focal point, the one at optic center will get through the same path, but they virtually tend to meet somewhere here. A dash, this is the height of the object, AB. The image formed will be A dash, B dash. It will be virtual. Why it is virtual? Because it is on the same side of the object. So it is virtual and erect. It will not be inverted. Last, we will see that of the image formation by concave mirror, concave lens. So there are only two conditions here. Here is f1. This is the optic center. Now if you're going to keep the object at infinity, so if you're going to keep the object at infinity, now the rays at some point infinity, the incident light will actually get diverged away, and they tend to meet at this focus point. Likewise on here also it will get diverged away and tends to meet at this infinity. Alright. So you will get the image at f1. You will get the image here, and it will be high, it will be very much smaller, diminished, point sized, and it will be virtual and erect. Why it is virtual? Because it is on the same side as that of the placement of object. Now I am going to, for the second case, I am going to keep the object between infinity and optical center, wherever it may be. So suppose you are keeping it here. My instant light will tend to diverge here, and it will virtually, and it will appear to meet at f1, and the rays which are passing through optical center will go through it. So the intersection of this point, if this is AB, this will be A dash, B dash. This is the place where your image is formed, and it will be virtual and erect, and it will also be small, but not as small as in this case. That is all for this sign convention and image formation. Thank you.